So, like when you are in a freshie mindset, you have all these doubts. How do I join the club? How do I do this? How do I do that? Well, like it's pretty simple. You just, you just be a part of that community. And how to be a part of the community? There are no prerequisites. You just need that enthusiasm, that, zeal to be the, zeal to follow aero modeling. That's it. Then you are part of the club. You are part of our catering circles and nothing else. So yeah, I just wanted to say that. Now I'll hand over to Piyush, who has like prepared something for you, as you can see in the screen. Yeah.
Yeah, welcome again. As you all of you
Piyush, your voice is a bit feeble.
Hello, am I audible now?
Yeah.
Yeah, 1 second. Yeah, I guess now I'm audible. Hello.
Yes, yes.
Yes, you're audible now.
Yeah, sure. So yeah, all of you have many questions like who are we, what do we do? You will get to know all this as orientation proceed, but as of now, I want you to be like focus on this photo. So like what do you understand by this photo? So these are basically our seniors or like our alumni who like basically made their planes, etc., and like uh, cater all the like resources and use that resources to actually make that what they want to make. So at the top right corner, you can see that there are 4 people standing with a plane and then some device. So it is basically a altitude hold RC plane. So they made it from scratch. And like you can see that fighting against the wind since 2003. So yeah, our club is like established in 2003. So yeah, we are doing these things from 2003. Sounds cool, right? So these are some glimpses of what we are doing over the years. So basically students come and you can see in that middle right photo, student come and sit, make their planes, enjoy together, and some learns from others, some teach others. So yeah, as also Jai told ki club is not a body run by 12, 13 people. Aeromodeling, basically in the Aeromodeling club, it is a community of hobbyists. Like some of you are wondering that we don't even know anything about aeromodeling or RC planes or anything, then how we will fit in this community. That's why we are here to provide you with all the resources by which you can get a feel of this amazing hobby. So let me also tell you one thing that I also don't know anything when I join institute. I first get to know about these things in orientation itself. So it's never too late. You can like also part of this hobby. And यार engineering college है कुछ तो engineering का भी explore करना ही चाहिए. And I can assure you that you will get real feel of engineering here only. So yeah, now hand over to Mihir. He will like tell you what we have for you.
Okay, thank you, Jay. Thank you, Piyush. So, as they said that like Aeromodelling Club is a group of aeromodeling and aviation enthusiasts who have an innate desire for flying. So now the question is like, what does club do? Like, any guesses? You can write in chats. Okay. So the question is what we do. We here at Aeromodelling Club organizes many workshops, hackathons, projects, and projects also like online as well as offline. We organize many competitions like RC plane competition, glider making competitions. We also mentors projects related to Aeromodelling Club. Like if you have any idea like to make something which is related to indirectly or directly to aeromodeling, we will mentor you. So our objective is to unify that these like-minded enthusiasts on a common platform and do something exciting in new ways. So now we have Amar and Swarna who will introduce you all to some of our club events. So okay, over to you, Amar.
Am I audible?
Yes, you are audible.
Yeah. So hello everyone, I'm Amar Barbiwala, sophomore in the aerospace department, and I'm also one of the conveners of the Aeromodelling Club. So I'll be telling you about the club's various events and how you can take part in them during your fresh year. So as stated before, the club conducts a variety of events ranging from competitions, hackathons, talk session and projects. So let's get started with the various competitions the club organizes, with the first one being Trivia Jet. Next slide, please. So Trivia Jet is an annual aviation quiz conducted by the club in the months of June and July. The quiz consists of interesting questions ranging from aviation history to current breakthroughs in aviation along with space exploration. So Trivia Jet receives a participation from colleges all across India. Did you know that as of now there is no IITB team which has ever won Trivia Jet? So we are hoping that a team from your batch will hopefully win Trivia Jet this year. So are you guys excited to win Trivia Jet this year? Okay. Okay, thank you for the wishes. Yeah. Yeah, so okay. Aero GPS, yeah, sure. So Trivia Jet finals, let me continue on Trivia Jet. So Trivia Jet finals consist of many engaging and thrilling rounds, which can be seen from the review of a Trivia Jet participant below. The quiz was like a roller coaster ride, had a one hell of an adrenaline rush. So as you can see, Trivia Jet is a very exciting and a fun-filled event, which you should look out to participate and hopefully win Trivia Jet this year. Hashtag it's coming home for all the football fans out here. Okay, so next slide, please. So the second competition that we have is Boeing Aeromodelling competition. So as the name suggests, we organize this event in collaboration with Boeing. In the competition, the students had to design a glider and launch mechanism, which was optimized for maximum endurance. So do you guys know what endurance means in flight? Write your answers in the chat. Okay. Do you guys know what endurance means in flight? Write that down in the chat. We'll see. Yes, exactly. One of us won it too. Yeah, so Ashita and Surajan, yes, exactly. So endurance basically means flight time and basically the ability to fly for a longer period of time. So yes, Kriti, the glider actually flew for over 3.5 minutes, I think so. But Harshit can add on to this more. So note that we'll also be teaching you how to make a glider after this orientation, which will hopefully motivate you to participate in the competition, which will be organized later this year. The club also conducted a few webinars on glider design to help the participating teams. The team with the highest flight time, or as I said, endurance, is the highest flight time, were selected as a winners. So the prize pool was a whopping 2,17,000 rupees. Yes, you heard me right. It was 2,17,000 rupees. Or as I quote Raju from Fir Hera Feri, "Paisa hi paisa hoga." You guys might know that scene, right? So, okay. So now I'll let Swarna tell you more about the industrial hackathons organized by the club. Yeah, over to you, Swarna.
I am also a convener of the Aeromodelling Club. I am a sophomore in the chemical engineering department. Now I'll tell you about some of the hackathons that are organized by our club. First is the Drona Aviation Hackathon. So the club conducted a drone programming hackathon in collaboration with Drona Aviation. What was the aim of the event? It was to give hands-on experience on drone programming using Cygnus ID and Pluto blocks and learning the flight mechanics of drones. We also conducted sessions on aerial robotics in which we covered the basic dynamic and control aspects of drones and control and navigation of drones. And after that, the participants solved the problem statement provided and implemented them on drones. Now, next, coming to the technical GC. You might be familiar with the term General Championship. An entire movie was based on this. Any guesses what that movie is? Yeah. Right. Okay. So this year the Technical Industrial Challenge was organized in October. And again, we collaborated with Drona Aviation. Now, what the problem statement was, it included two-dimensional obstacle avoidance using UV sensors and PID control. The competition comprised of 2 rounds, where in the first round, the participants were required to come up with an algorithm which would help in integrating UV sensors and using them in obstacle avoidance without the use of loops. Now, 5 teams from this round were selected and they were given a drone to integrate their code with it and complete the problem statement. Now, over to you, Amar.
Okay, so you might think that all these competitions are okay, but what if I'm more interested in learning and exploring stuff? So don't worry, we have got you covered. And now we will tell you about the different courses and the talk sessions conducted by the club where you can learn about stuff. So the first one being Aerocast Talks. So Aerocast Talks was obviously, as you can see from the name, it was Aero Plus podcast. So Aerocast Talks was a collaboration between us and CDSSRG. So as you might have seen in the ITC orientation, do you guys know the full form of CDSSRG? Yeah, write that down in the chat. Let's see who gets this right. CDSSRG. Yes, yes, exactly. We'll share the recording. Don't worry. Yes, Akshat is right. Control is a part of that. Chief of Defense Staff. No, 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 not that. Okay, so CDSSRG is basically stands for Controls and Dynamical Systems. Yes, exactly, Pal Agarwal, you were right. Controls and Dynamic Systems Student Reading Group. So this talk series covered various interesting topics in aerial robotics, controls, and engineering, such as thrust vectoring, VTOL, ornithopter, and autonomous drone. We had invited experienced guest speakers who have worked in their respective fields for the talks on these topics. And also based on these topics of the talk, Aerocast projects were also launched, and the speakers of these sessions mentor these projects. And more on these projects can be covered later. Yeah, Swarna can continue from here.
Yeah, next about aerial robotics. So we launched a 3.5 week long course on aerial robotics, which is meant introduction to the realm of quadcopters. So all of you might be familiar with the term drones. So how do we go about creating these agile micro aerial vehicles that are able to operate autonomously? Yeah, or as we know them, drones. So here in this course, the aim was to provide an introduction to flight design of quadrotor flying robots. And here we dealt with understanding how do these quadrotors maneuver in complex 3D environments, and finally, what are the practical applications that these might be put into, like military and other purposes. Next, yeah, suppose you want to design an aircraft from scratch. What are the components that you would require? What important aerodynamic concepts that are there that you would keep in your mind while designing it? Don't worry, we have got you covered. We organized a 4-week course on aircraft design and stability analysis using XFLR 5. Okay, any ideas on what XFLR 5 is? Okay, you might put the answers in the chat. The contents of the course covered various aspects like wing configuration, component selection, battery weight estimates, tail design, weight iterations, etc. So also a note, this course was launched under TSS, which is an ITC initiative, where we have a plethora of online courses, and it's really a wonderful utilize summer vacations and explore. So do check it out. Over to you, Amar. Yeah.
Yeah, so here's a snippet from the Shakespeare in Shakespeare English. Thee may ask, but sire, what about us? At the hour we return to the campus. Do thee hast aught planned for us then? To which we replied, don't worry, we have stuff planned for thee in offline too. So for those like me who do not understand Shakespeare in English, it basically says that when you return to the campus in second STEM, I quote hopefully, and we have some exciting events planned for you in offline too, in case you return in second SEM. And please don't come after me if they're still online in second SEM too. So yeah, Swarna can continue from here.
Yeah. Coming to RC Plane. RC Plane is the flagship event of our club. It's a team-based event, and people participate in teams of 4 are formed. Now, in this event, we conduct all the sessions. There are no prerequisites. Like we cover all the theoretical aspects, the design session, simulator session, practice session, before the final showdown in the competition. And it is probably going to be a first step towards radio control flight. Trust me, nothing beats the contentment of spending a chill weekend with your friends, designing and building your first RC plane, and going to the Gymkhana grounds and watching it fly smoothly. Or so you might expect. Because, hold up, what if it crashes? it will crash. And in fact, it will crash multiple times, as we have heard it from our seniors, because surprise, surprise, we too were online freshies and we weren't able to participate in this wonderful event. Now, over to you, Amar.
Okay, so yeah. So now let's say in an offline semester, you want to learn to fly an RC plane. Okay, so I guess this is a small video of Team 9. So yeah, before I continue, I'll just want a request Harshit to play this. Also quite a bit nice name there, Team 911. As you can see, the video was quite a bit quite nice, and we have these gymkhana grounds where you can practice flying and also do a bit of flying there. So we held our RC plane finals there, where each team showcased their RC plane and flew that. Okay, please don't cancel me. Sorry, I'm sorry for the name. Okay, wait, FBI is here. Sure, so let's continue. So now let's say in an offline semester, you want to learn how to fly an RC plane, or suppose you want to flex your piloting skills, which you learned in the RC plane competition in front of your crush. We got you, bro. So Lukka flying sessions are weekly sessions held in the Gymkhana grounds where you can learn flying an RC plane. Unfortunately, online conveners like me haven't yet experienced Lukka flying session, so we can have F's in the chat for us, as online conveners. But we have heard from our seniors that it is a lot of fun. So yeah, these were some of the exciting events the club conducts, and we hope to see you at these events. Now I'll hand it over to Isha, who will briefly discuss with you the club's achievement. Over to Isha.
Hello aeronauts, myself Isha Mukherjee. I am a sophomore student in the Department of Aerospace Engineering, and also, as you might have guessed, a convener in the Aeromodelling club. But I am an offline convener. So I'm gonna speak about the achievements of our club members. So let us begin. Next slide. The first achievement that I'm very glad to share is that our team, consisting of our manager Piyush and 3 conveners, Ajay, Anjali and Akshat, achieved the first runners-up position in Aerospanza. That is a national level competition where the challenge, as we always love to take up challenges, was to design a launch pad for sound-in rockets, as you can see in the figure. This was made using ANSYS software, and as you participate in such competitions, you will get to learn such interesting and exciting softwares. Next. The next was the Skydish competition, in which our team of 2020 achieved first position among all participants of the country. It was organized by Manipal Institute of Technology, MIT, as many of you might say. This time, the challenge was to design a fixed-wing aircraft that was capable of successfully accomplishing missions which involved dropping multiple payloads at different dropping zones. This was also a very good achievement for our club members. Next. Next challenge was a very proud moment in my life. In this, we, a team of 3, participated in a national level design challenge in which we had to design a rocket with given constraints. The name of the competition was Synodic Rocket Design Challenge. The designing had to be done using open rocket software, and it was really a proud moment for us when we achieved the required apogee and optimum payload capacity, and we secured the second runners-up position. Now, can you guess which 3 conveners are there in the photo with the trophy? Of course, that was a bit bragging off. You can write it in the chat. Now, we are still thriving. We are on the way to achieve many more competitions and milestones. There are many more milestones to achieve and many more interesting problem statements to crack. As I end with the words of Robert Frost, I have promises to keep. and miles to go before I sleep. Now I hand over to my fellow convener Akshat to speak about his project.
Hey freshers, welcome once again. Yeah, so I am Akshat Verma, a sophomore in mechanical engineering department, and as you know, one of the club conveners. So till now, my co-conveners have given you a really good, beautiful exhibition of what insightful events we have got in stores for you. Now let's move to something which would really interest you a lot, and that's projects. Yeah, some cool and exciting projects under the club, which you can also be a part in the future. So first in the line is the Tilt-rotor transitioning VTOL, which me and my co-convener Rajiv Durandar have been leading. Rajiv is not here today. Maybe he's planning something interesting for you that's coming up. Spoiler alert, it's related to rockets maybe. So before I start telling you that what do we do in this project, let's play a bit of guessing game. Can you guess this aircraft in the image here? I think we have got some really good aero modelers or aviators here. Let's see, can you guess this image? Which aircraft is this? Let me see if you can answer it in the chat. No, not Chinook. Okay, yeah, it's a military aircraft, but which one? Okay. That's definitely a VTOL. Okay, no issues. So this aircraft is called V-22 Osprey, and this is a very famous US military aircraft. Yeah, right. Yes, you're right. You answered it correctly. That's and these questions will also be in a trivia jet, guys. So many of you were willing to win trivia jet, right? So take note of these questions. Maybe this is one of those. So yeah, so V-22 Osprey is a US military aircraft. Now this is something we call our transitioning VTOL aircraft. Now what a VTOL is? So you might know what a VTOL is. Do you know the definition of a VTOL or a full form of a VTOL? Let me know in the chat if you do. Vertical takeoff, yeah. And what does the L stand for, Kushal? That's pretty close. Yeah, let me see if I get some more answers. Yeah, right, landing. So VTOL is a vertical takeoff and landing aircraft. Now all that is fine, cool. So let me ask you a question. Let's suppose you are a military pilot. Yeah, and you got a fighter jet. Ooh, that cool, isn't it? Yeah, and you have to go from one position to another, but all you've got to take off and land is just a small ship, and that cannot provide you the required runway, right? So you have to go from one location to another. You are a military pilot, and you just got a ship to take off and land. So will you be able to do that mission without such a runway with a simple jet aircraft? What do you think? Let's see if we got some really cool future pilots here. Maybe some of you can go to future pilots. Okay, so some of you are answering with a helicopter, some of you are answering no. Starship, I don't know what you are saying. Okay, so all right, so not possible, right? Without the runway, you would not possible to take off and land just on a small ship. Now, what if I tell you that if you had a V-22 Osprey or a similar aircraft, you would be able to do that mission? Interesting, isn't it? So what's so special about V-22 Osprey's design? So as you can see in this slide, this aircraft is a beautiful combination of two existing aircraft technologies. That is the simple fixed wing aircraft, which requires runways, and the rotor crafts like drones or helicopters or something. So the cool thing in this aircraft is that this aircraft can transition between the two modes. So when you are, let's say you are a normal fixed wing flight, which you generally travel in, and suddenly you have a urge that you want to fly in a drone or say in a helicopter, all you have to do is just push a button and change the modes of the aircraft, and you are in a helicopter from then. So now you may ask me, some of you answered helicopter. So why don't use a helicopter? So the issue is, let's see, I have to go from one position to another, and that's a small distance. So by helicopter, that's really efficient, and I can do that. But whenever you are asked to travel larger distances, so that would be a very power consumption would be a very big issue there. So normal fixed wing flights are really power efficient as compared to simple drones or helicopters. So that's why we club them together. So what we do in this project is we club both the configurations together. We club the fixed wing with the drones, and we combine them and make a transitioning VTOL aircraft. So now can you tell me the mission I was talking to you about, how would you achieve it using V-22 Osprey? So the issue was with takeoff, right? So what would you do with the takeoff? Would you use the drone mode, the rotorcraft mode, or would you use the fixed wing mode? Which is the better one to take off with? Any guesses? Drone mode, right, right. Okay, so I'm getting many of you are answering drone mode. That's correct. So what we do in this project is we take off using the drone mode, and once we have reached the altitude and we have achieved certain velocity, we transition to the fixed wing mode. We go to the whole distance we cover, which we had to cover in the mission, and then again when we had to land, we again switch off to the drone mode and vertically land on the platform. That's interesting, right? Yeah. So next slide. That's what we do in our project. Yeah, so here are some cool designs of the same technology which we have analyzed, and there was also one prototype which you can see on the top in the right side of the slide. This was one of the prototypes which was made in a team by a team which is in institute currently. It didn't flew well, so we'll have to make some changes to it, and there are many such prototypes also which other peoples have made. So you can see there are some designs like this one in the middle, which middle and left, and which uses several rotors, and then there are some only which use just two simple rotors at the wingtips. So there are many designs like this. Next slide. Yeah, so that's our design, what we have done. So we have done some really extensive aerodynamic analysis on it, and we have prepared the design of our aircraft. We'll soon be making it physically, and when you guys reach campus, maybe you can accompany us to the Gymkhana grounds for a flight session. Yeah, any queries you may have regarding this doubt or the club in general or anything in general about the institute, you can ping me or ask through the chat. Yeah, that's all regarding my project. Handing over for the next project to Ajay, and yeah, Merry Christmas, guys.
Hello guys, I am Ajay Tak, sophomore in aerospace department and conveyor at Aeromodelling Com. First of all, I would like to apologize that none of my conveyors other than Akshat Verma have wished you Merry Christmas. So Merry Christmas to you all, and Merry Christmas to you all. And I'm very delightful to have you all today. To have you all on this occasion. So now I'm going to talk about thrust vector model rocket, a project which I, along with some of the co-conveyaners, are working on. So basically, we have two categories of rockets: fin control model rocket and thrust vector control model rocket. Generally, fin control model rockets are they does not require any external aid. That is, you don't have any control over the attitude of your rocket. Now, suppose that you launch the ideal fin control model rocket. By ideal, I mean something which is well built, right? So you will notice that the rocket goes straight up and it doesn't deviate from being vertical. So can any of the freshies guess why does the fin control model rocket doesn't deviate, although we don't have any control over it? Please type your answer in chat. Yes, Kushal, you are right. Actually, next slide, please. It's because of the fins. The fins produce lift force. Whenever your rocket will misalign from its path or misalign from being vertical, your fins will produce a lift force, and this lift force will produce the opposing torque that will realign your rocket to being vertical. Now, up till now, everything's good. It is stable. It is self-stabilizing. But there's a shortcoming, right? You don't have the creative space to make your rocket do different maneuvers, like to make it land. Right? So here comes thrust vector control to your rescue. Next slide, please. So in a thrust vector control model rocket, you don't have fins, but you have a special ability to change the direction of your thrust. You can see here the blue dotted line is the axis of your rocket, whereas the black dotted line is the direction of your thrust. As the direction of thrust is changed, you can see that that thrust force will cause a torque about the CG, whereas this torque will be in clockwise sense. But if this direction was changed, I mean, if this was tilted the other way around, then it would cause a anti-clockwise torque. This means that just by changing the direction of thrust, you can basically change the direction of your rocket. That is, you have complete control over your rocket when you have thrust vector control installed in your rocket. That means you can make your rocket to land. Now, another question for you, freshies. can anyone guess the space company's name, which comes to your mind when you hear about landing rockets? I think this should be easy for you all. Yes, Jithat. Yes, yes. It is SpaceX. Next slide, please. And we and we all conveyors were who are taking part in this project. We were inspired from actually SpaceX model rockets. You can see here Falcon Heavy rocket. They are using thrust vectoring to keep the rocket vertical and then decelerating in order to land. And the right one is the model rocket created by Joey B. I guess if any of you are a rocket enthusiast, then you may know Joey B. He has a YouTube channel named BPS Space. Now I have a spoiler alert for you all. We are going to have a event based on rocket in the near future. And before I hand over the stage to Harshit, I would just like to say, अच्छा चलता हूँ, दुआओं में याद रखना. See ya, guys.
So hello everyone. My name is Harshit Singh, and I'm also convener of the Aeromodelling Club. So as you can see in these images, I had made quite a few planes in the past, during my tenure and off tenure before the college even. Here you can see the simple cub, which one of your members in the group also made. And here are some other planes. Here is a Sportster, which flew really well. It's a really good flying plane. But as you can see, these are all very similar. You can see they all are made using the pretty much same technique. They're all flight test models and are conventional airplanes. But as you can see, I had made quite a few planes. Now I wanted to try something new, some new configuration or a new building technique. You know what, like some serious stuff rather than the simple home-built airplanes. And just at the moment, I saw a video of flight test, which you can see in the bottom right corner. Here they are showcasing their flight test arrows, which they have fiberglassed, and they demonstrated how strong and durable they are to crashes because they had fiberglass the whole plane with fiberglass cloth and epoxy over it. And they are really crash resistant, like you can crash them in wooden poles and they won't even get a scratch. So I wanted to try something like that, and so I started the project, which was the Phantom Wing, or you can say the Flying Wing project. So here's the thing, the time is of summer break, and since I wanted to start the project, I read a few books, which basically I read this book, the RC Model Aircraft Design, which luckily had a section on tailless aircrafts. And I did some research about past tailless aircrafts and also managed to build a few flight test models of the flying wing. Here you can see the Spear and the Arrow, which was a very recent build. But as you know, like I was trying very new things, and even that's why the biggest devil of all, the procrastination, stepped in. So basically I was trying very new things, like fiberglassing was absolutely new, and like cutting the airfoils out of foam in airfoil shape rather than folding them, and controlling the ailerons using bent wires rather than push rods. Like these were all new things, and they were all stacking up on each other and really were taking a lot of time. And the work of hours became days and days became months, and the summer break ended, unfortunately. But you know, the progress was slowly happening even during the semester. But now the winter break came, and this time during the winter break I decided like this was the time to make it happen. Like it had really taken a lot of time and a lot of effort during the past, and I was really struggling to make this project. But this time I realized that I had to finish this project. Like if I don't finish in the winter break, I won't be able to, because slowly I was even losing interest in the project, as it was stretched a lot of time, which is not usually I give that much to projects. So I finalized the dimension. Here you can see the CAD model I prepared using the dimensions I fixed, And the components I selected, the electrical components, the motors, the battery size and all, and ran a few simple analysis using the XFLA 5. And fingers crossed it ends this winter, because yeah, this is really a cool project. Like here you can see my current stage on the model. The model is all cut and the paper is stuck on over it. And these are all carbon fiber spars and fiberglasses all set. You can see it shining, and it's really hard and solid right now. So yeah, enough with the slides and photos. Let me show you my real projects. I guess many of you would be interested in them. So just a minute. I guess my video is highlighted, right?
Yeah, you can stop the screen sharing. Meanwhile.
All right, so you can see all the planes I have built in the past. They are hanging on the wall. I like to keep them these ways, as they take less space in my room and also look very good on the wall. And like I would showcase some of them. So this was the first plane I ever built. So this was the flight test simple cup. You can see all the decals and paint, and it looks very nice. But don't go on the looks. Like this has never flown a single time nicely, because all the weight added due to the paint. So yeah, in the future, if you are trying to build something, do make sure it is less on weight. Like that would be a very crucial issue and to something to be thought of. Like don't go overweight. Like they don't fly very nice if they are overweight. And this is my favorite plane of all. Like here's the flight test simple cup. Some modification I made, like I made the fuselage smaller than it was supposed to be. And it flies really well. As you can see, the lines are really smooth, and the fuselage is narrower than the usual Sportster. It's a low wing design. You can see it's all like flat on the bottom. It flies really nice and it's really maneuverable. And you can also see the flying wing I made. It's now really old and I've flown it a lot. It has taken a lot of beating. I don't usually fly these days. It has been replaced by this thing. So this I recently made during the project only. Like I was really bored of the project. It was taking a lot of time and effort, so I just got hands of some foam and built this flying wing to replace that one bigger one. You can also see some of the planes are also lying over there like that. This was supposed to be a 3D plane, profile plane, which I drew it myself on the CAD from the, if anyone knows the precision aerobatics, they built these. And here you can also see the Boeing glider which I used. Like you must have been told about the Boeing competition about the gliders. So this was my entry in that competition. It's carbon fiber fuselage with balsa and foam wings. It is really lightweight. Like everyone, each of them are like under 9 grams. They fly really smooth and they're very elegant and flat. And as you might have already known that you will also be making gliders in your glider making workshop. So if you all follow the instructions, like this should be the glider you would be making in the end, which has almost the similar dimensions, but we haven't chosen the elliptical ones, like because some of you might not have easy access to printers and all to print the ellipses. So we made these rectangulars so everyone can just use a scale and pencil to draw them and I'm sure many of you have already cut the pieces, so it would be very easy and time efficient to make these. So if anyone, many of you would be excited to see how these fly, so I would just do a simple demonstration of how well these gliders would fly if you make them correctly. So like this is the glider, and if you fly them nicely, you should just go over there. So you can see these fly really well if you are concentrating on weight, like don't make it overweight. All right, so they should also fly really nice like this only. So I would just on the slideshow. So now handing over to Gaurav, who would guide you to the glider making workshop.
Hello everyone, I'm Gaurav Sharma. Hello.
Yeah, Gaurav, you're audible.
Hello everyone, I'm Gaurav Sharma, sophomore in the aerospace department and one of the convener of Aeromodelling Club. For more detailed info on the club projects and other club activities, you can visit our club website or scan the QR code given in this slide. I hope you all enjoyed our orientation session. Now we have a glider making workshop for all of you, for which you have to leave this meet and join the meet started in private channels on MS Teams group where your mentors are waiting for you. Prepare all the materials required for the session as instructed earlier. In case of any doubts, you can unmute or ask in the chat box. Thank you.